Dear students, very good morning to all of you. Today we are going to start a new lesson called beta and gamma function. This is the first lecture of this lesson. In this lecture we are going to learn about definition of beta and gamma functions and relationship between them. The beta function is defined as beta of m comma n is equal to integration from 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 into dx, where m is greater than 0, n is greater than 0 and need not be integers. This integral is also called the Euler's integral of the first kind. Beta function is symmetric in nature with respect to interchange of indices, that is beta of m comma n is equal to beta of n comma m. Let us put 1 minus x is equal to y, then x is equal to 1 minus y. This implies that dx is equal to minus dy. Also when x is equal to 0, y is equal to 1, and when x is equal to 1, then y is equal to 0. Therefore we have beta of m comma n is equal to integration from 1 to 0 1 minus y to the power m minus 1 into y to the power n minus 1 into minus gy. Therefore beta of m comma n is equal to minus integration from 1 to 0 y to the power n minus 1 into 1 minus y to the power m minus 1 dy. This gives beta of m comma n is equal to integration from 0 to 1 y to the power n minus 1 into 1 minus y to the power m minus 1 into dy. This is equal to beta of n comma m. The relation beta of m comma n is equal to beta of n comma m can also be proved as follows. From the definition of beta function, we have beta of m comma n is equal to integration from 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 into dx. Now using the rule of definite integral 0 to a f of x dx is equal to integration from 0 to a f of a minus x dx, we have beta of m comma n is equal to integration from 0 to 1 minus x to the power m minus 1 into 1 minus x to the power n minus 1 to the power n minus 1 dx. So beta of m comma n is equal to integration from 0 to 1 minus x to the power m minus 1 into x to the power n minus 1 dx. This gives beta of m comma n is equal to integration from 0 to 1 x to the power n minus 1 into 1 minus x to the power m minus 1 into dx, which is equal to beta of n comma m. Therefore beta function is symmetrical in nature with respect to the interchange of indices. Transformations of beta functions are beta of m comma n is equal to 2 into integration from 0 to pi by 2 sine to the power twice m minus 1 theta cos to the power twice m minus 1 theta d theta. Beta of m comma n is equal to integration from 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n dx. This is also equal to integration from 0 to infinity x to the power n minus 1 divided by 1 plus x to the power m plus n dx. Also we have beta of m comma n is equal to integration from 0 to 1 x to the power m plus 1 plus x to the power n minus 1 divided by 1 plus x to the power m plus n dx. Let us prove that beta of m comma n is equal to 2 into integration from 0 to pi by 2 sine to the power twice m minus 1 theta cos to the power twice n minus theta d theta. Now we know from the definition of beta function that beta of m comma n is equal to integration from 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Now let us substitute x is equal to sine square theta. This gives us dx is equal to 2 sine theta cos theta d theta. Now when x is equal to 0, then theta is also equal to 0. When x is equal to 1, then theta is equal to pi by 2. Therefore equation 1 becomes beta of m comma n is equal to integration from 0 to pi by 2. So x is sine square theta, we put the value here, so we get sine to the power 2m minus 1 theta into 1 minus sine square theta to the power n minus 1. Dx is 2 sine theta cos theta d theta. So this gives us 2 into integration from 0 to pi by 2 sine to the power twice m minus 2 plus 1 theta cos of 2 to the power cos of twice n minus 2 plus 1 theta d theta, and which gives beta of m comma n is equal to 2 into 0 to pi by 2 integral of sine to the power twice m minus 1 theta cos to the power twice n minus 1 theta d theta. Let us prove that beta of m comma n is equal to integration from 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n dx is equal to integration from 0 to infinity x to the power n minus 1 divided by 1 plus x to the power m plus n dx. Now we know that beta of m comma n is equal to integration from 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Let us put x is equal to 1 by 1 plus y. This gives us dx is equal to minus 1 by 1 plus y square dy. Also 1 minus x is equal to 1 minus 1 by 1 plus y is equal to y divided by 1 plus y. When x is equal to 0, then we get y is equal to infinity, and when x is equal to 1, then y is equal to 0. Therefore, equation 2 becomes beta of m comma n is equal to integration from infinity to 0 into 1 by 1 plus y to the power m minus 1 into y by 1 plus y to the power n minus 1 into dx is equal to minus 1 by 1 plus y whole square dy. Therefore, this becomes equal to beta of m comma n is equal to integration from 0 to infinity y to the power n minus 1 into 1 divided by 1 plus y to the power m minus 1 plus n minus 1 plus 2 dy. Therefore, beta of m comma n is equal to integration from 0 to infinity y to the power n minus 1 divided by 1 plus y to the power m plus n dy. We can write this expression as 0 to infinity integral of x to the power n minus 1 divided by 1 plus x to the power m plus n dx, because integration from 0 to infinity f of y dy is equal to 0 to infinity integral of f of x dx. Therefore, beta of m comma n is equal to integration from 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n dx. Since beta function is symmetrical about the indices m and n, that is beta mn is equal to beta of n comma m. Prove that beta of m comma n is equal to integration from 0 to 1 x to the power m minus 1 plus x to the power n minus 1 divided by 1 plus x to the power m plus n dx. Now we know that beta of m comma n is equal to integration from 0 to infinity y to the power n minus 1 divided by 1 plus y to the power m plus n dy. Now we can write this as beta of m comma n is equal to 0 to 1 y to the power n minus 1 divided by 1 plus y to the power m plus n dy plus integral from 1 to infinity y to the power n minus 1 divided by 1 plus y to the power m plus n dy. Let us now take the second integral and let us put I2 is equal to integral from 1 to infinity y to the power n minus 1 divided by 1 plus y to the power m plus n dy. Now let us substitute y is equal to 1 by z. This gives us dy is equal to minus 1 by z squared dz. When y is equal to 1, then z is also equal to 1. When y is equal to infinity, then z is equal to 0. Therefore, we have I2 is equal to integral from 1 to 0 z to the power 1 minus n divided by 1 plus 1 by z to the power m plus n into minus 1 by z squared dz. That is I2 is equal to integration from 0 to 1 z to the power 1 minus n into z by 1 plus z to the power m plus n into z to the power minus 2 dz. Therefore, we have I2 is equal to integration from 0 to 1 z to the power 1 minus n plus m plus n minus 2 divided by 1 plus z to the power m plus n dz. So n and n cancels out, and this is 1 minus 2, which is equal to minus 1. So therefore, we have I2 is equal to integration from 0 to 1 z to the power m minus 1 divided by 1 plus z to the power m plus n dz. Therefore, equation 3, this becomes equal to integration from 0 to 1 y to the power n minus 1 divided by 1 plus y to the power m plus n dy plus integration from 0 to 1 z to the power m minus 1 divided by 1 plus z to the power of m plus n dz. So therefore, we can write down this beta of m comma n is equal to integration from 0 to 1 x to the power n minus 1 divided by 1 plus x to the power m plus n dx plus integration from 0 to 1 x to the power m minus 1 divided by 1 plus x to the power m plus n dx. Because here y and z, they are dummy indices and can be replaced with any index. Here we have replaced y and z with the index x. So therefore beta of m comma n is equal to integration from 0 to 1 x to the power m minus 1 plus x to the power n minus 1 divided by 1 plus x to the power m plus n dx. Gamma function. Now gamma function is defined as gamma of n is equal to integration from 0 to infinity e to the power minus x to the power n minus 1 dx, where n is greater than 0. This integral is also known as Euler's integral of the first kind, and gamma of 1 is equal to 1. So we put n is equal to 1 in this integral, then we get gamma of 1 is equal to integral from 0 to infinity e to the power minus x dx, and integral of minus e to the minus x dx is equal to minus e to the minus x, and lower limit is 0, upper limit is infinity. So we put the respective lower and the upper limits, and we get gamma of 1 is equal to 1. Now gamma of n plus 1 is equal to n gamma n, and this is also equal to n factorial. So gamma of n plus 1 is equal to, we put n is equal to n plus 1 in this case, and therefore we get gamma of n plus 1 is equal to infinity e to the minus x to the power n dx. Now we do carry out an integration by parts, and we get minus x to the power n e to the minus x, lower limit is 0, upper limit is infinity, plus n into integration from 0 to infinity e to the minus x to the power n minus 1 dx. Now this quantity is equal to 0, because if we put the lower limit and the upper limit, we find that this value comes out to be equal to 0. Therefore gamma of n plus 1 is equal to n into gamma n. Now for n is equal to 1, we see that it becomes gamma 2 is equal to 1 into gamma 1. So now gamma 1 is equal to 1, so therefore we get gamma 2 is equal to 1. For n is equal to 2, we get gamma 3 is equal to 2 into gamma 2. Now gamma 2 is equal to 1, and this becomes equal to 2, and we can write down this as 2 factorial. For n is equal to 3, we have gamma 4 and is equal to 3 into gamma 3. So this is 3 into gamma 3 is already we have found that this is equal to 2, so this comes out to be 6. So 6 is nothing but 3 factorial. For n is equal to 4, we have gamma 5, so we can write down this as 4 into gamma 4, which is equal to 4 into 6 is equal to 24, and is equal to 4 factorial, and so on. So therefore we have gamma of n plus 1 is equal to n into gamma n is equal to n factorial. Now transformations of gamma functions, wait for a moment. Integration from 0 to infinity e to the minus x to the n minus 1 dx is equal to gamma to the power n divided by alpha to the power n, where alpha is greater than 0, n is greater than 0. Beta of m comma n is equal to gamma of n divided by gamma of m plus n. Similarly, gamma of m into gamma of 1 minus m is equal to pi by sine of m pi, where m lies between 0 and 1. Gamma of half is equal to square root of pi. Prove that gamma of m plus gamma of m comma n is equal to gamma m into gamma n divided by gamma of m plus n. Now we know that gamma of m is equal to 0 to infinity integral of e to the minus t to the m minus 1 dt. Now let us substitute t is equal to x square. So this gives us dt is equal to twice x dx. Therefore we have gamma of m is equal to integral from 0 to infinity e to the minus x square to the power m minus 1, and dt is equal to twice x dx. Therefore we get gamma m is equal to 2 into integral from 0 to infinity e to the minus x to the power twice m minus 2 plus 1 dx. So this gives gamma m is equal to 2 into integral from 0 to infinity e to the minus x square to the power twice m minus 1 dx. Similarly, we can write down gamma of n is equal to 2 to the power 2 into integration from 0 to infinity e to the minus y square y to the power twice n minus 1 dy. So therefore if we multiply these two, gamma m into gamma n, so we get that gamma m into gamma n is equal to 4 into integration from 0 to infinity into integration from 0 to infinity. This is with respect to x, this is with respect to y, and e to the power minus x square plus y square x to the power twice m minus 1 into y to the power twice n minus 1 dx into dy. Now this the integral, we can see that the region of integration lies in the first quadrant, because x goes from 0 to infinity and y goes from 0 to infinity. So therefore this integral lies in the first quadrant, and we change this to polar coordinate In polar coordinate, we know that x is equal to r cos theta and y is equal to r sin theta, and dx dy is equal to r dr d theta, where r goes from 0 to infinity and theta goes from 0 to pi by 2, because x and y lies in the first quadrant. Therefore, we have gamma m into gamma n is equal to 4 into r is equal to 0 to infinity, theta is equal to 0 to pi by 2. Now e to the minus r square, x is equal to r cos theta, we put the value of y, r sin theta, and dx dy is equal to r dr d theta. So therefore we can separate this integral into r integral and the theta integral. So we find that this is nothing but the beta of m comma n. This is a beta function, and therefore gamma m into gamma n is equal to 2 into r is equal to 0 to infinity e to the minus r square, r to the power twice m plus n minus 2 into r dr into beta of m comma n. Now we can further write down this as beta of gamma of m into gamma n is equal to integration from r is equal to 0 to infinity e to the minus r square, r square to the power m plus n minus 1 into twice r dr into beta of m comma n. Now let us evaluate this integral. So let this integral is equal to I. So now let us substitute r square is equal to s. Therefore we get twice r t r is equal to ts. So therefore we can write down this integral I is equal to integration from 0 to infinity e to the minus s and s to the power m plus n minus 1, and this twice r dr is nothing but ds, and this is nothing but gamma of m plus n. So therefore equation 4 becomes gamma m into gamma n is equal to this quantity. We have already found that it is gamma of m plus n multiplied by beta of m comma n. So from here we find that beta of m comma n is equal to gamma m into gamma n divided by gamma of m plus n. Now let us prove that integration from 0 to infinity e to the minus alpha x to the power n minus 1 dx is equal to gamma n divided by alpha to the power n. So let us substitute alpha x is equal to y, and from here we find alpha dx is equal to dy, and this gives dx is equal to dy by alpha. Also x is equal to y by alpha. When x is equal to 0, then y is equal to 0. Also when x is equal to infinity, then y is also equal to infinity. Therefore this integral 0 to infinity e to the minus x alpha x into x to the power n minus 1 dx is equal to 0 to infinity integral of e to the minus y. Now x is equal to y by alpha, so this can be written as y by alpha to the power n minus 1 into dx is equal to dy by alpha. So therefore we can write down this as alpha into 1 minus n minus 1 into integration from 0 to infinity e to the minus y to the power n minus 1 dy. So we get this equal to alpha to the power minus n. This is the definition of gamma function, which is gamma of n. Therefore this becomes equal to gamma n divided by alpha to the power n. Prove that gamma of half is equal to square root of pi. So we know that gamma of n is equal to 0 to infinity e to the minus x to the power n minus 1 dx. Now we substitute n is equal to half, so we get gamma of half is equal to 0 to infinity e to the minus x into x to the power half minus 1 dx. So this gives gamma of half is equal to integration from 0 to infinity e to the minus x to the minus half dx. Now let us substitute x is equal to y squared. From here we get dx is equal to twice y dy. Therefore we have gamma of half is equal to integration from 0 to infinity e to the minus y squared into y to the minus 1 into 2y dy. This is equal to 2 into integration from 0 to infinity e to the minus y squared dy. So also we can write down this gamma of half in terms of another dummy variable, let's say x. So therefore we can write down gamma of half is equal to 2 into integral from 0 to infinity e to the minus x squared dx. Now we multiply this two. So gamma of half into gamma of half is equal to 2 into integration from 0 to infinity e to the minus x squared dx multiplied by 2 into integration from 0 to infinity e to the minus y squared dy. So this gives us gamma of half is whole square is equal to 4 into integration from 0 to infinity into integration from 0 to infinity. This is x integral and this is the y integral, and e to the minus x square plus y square dx dy. Again, here x goes from 0 to infinity and y goes from 0 to infinity. Therefore, this integral lies in the first quadrant, and let us change to polar coordinates. X is equal to r cos theta and y is equal to r sin theta, and dx dy is equal to r dr d theta, where r goes from 0 to infinity and theta goes from 0 to pi by 2. So therefore, we get gamma of half squared is equal to 4 into r 0 to infinity theta 0 to pi by 2 integral e to the minus r square r dr d theta. Now we separate the r integral and theta integral, and this theta integral is nothing but it's pi by 2. So we get 4 into pi by 2 multiplied by this r is equal to 0 to infinity e to the minus r square r dr. Now this can be written as is equal to minus half of into r is equal to 0 to infinity ddr of e to the minus r square dr. Now this gives us minus pi into the integral of this expression is e to the minus r square. Lower limit is 0, upper limit is infinity. So we put the upper limit and the lower limit, and we get this equal to minus pi into the minus infinity minus 1. Now e to the minus infinity is equal to 0, and therefore we get gamma of half whole square is equal to pi. This gives gamma of 1 by 2 is equal to square root of pi. So that gamma of n is equal to integral from 0 to 1 log of 1 by y to the power n minus 1 dy, where n is greater than 0. Now we know that gamma of n is equal to integration from 0 to infinity e to the minus x to the power n minus 1 dx, where n is greater than 0. Now let us substitute y is equal to e to the power minus x. This gives us log y is equal to minus x. Therefore we have x is equal to log of 1 by y, and therefore if we take a derivative differentiation, so dx is equal to minus 1 by y dy. Now when x is equal to 0, then we get y is equal to 1. Also when x is equal to minus x is equal to infinity, then we get y is equal to e to the minus infinity, which is equal to 0. So therefore we have gamma of n is equal to integral from 0 to infinity e to the minus x to the power n minus 1 dx. It is equal to now can be written as integral from 1 to 0 into y into log of 1 by y to the power n minus 1, and dx is equal to minus 1 by y dy. So therefore we can write down this gamma of n is equal to this minus sign is absorbed in changing the order of the integral. So we can write down this 0 to 1 log of 1 by y to the power n minus 1 dy. Prove that beta of m comma half is equal to 2 to the power twice m minus 1 beta of m comma m, and gamma m into gamma of m plus half is equal to square root of pi divided by 2 to the power twice m minus 1 into gamma of twice m. Let us first prove the first relationship. We know that beta of m comma n is equal to 2 into integration from 0 to pi by 2 sin to the power twice m minus 1 theta cos to the power twice n minus theta d theta. Now we put n is equal to half here, so therefore beta of m comma half is equal to 2 into integral from 0 to pi by 2, and here if we put n is equal to half, this becomes cos to the power 0 theta, which is equal to 1. So therefore we get beta of m comma half is equal to 2 into integration from 0 to pi by 2 sin to the power twice m minus 1 theta d theta. Again putting n is equal to m in this equation, we get beta of m comma m is equal to 2 into integration from 0 to pi by 2 sin theta cos theta to the power twice m minus 1 d theta. So we know that sin 2 theta is equal to 2 into sin theta into cos theta. Therefore we put sin theta cos theta is equal to sin 2 theta by 2. So therefore this becomes equal to 1 by 2 to the power twice m minus 2 integration from 0 to pi by 2 sin of sin to the power twice m minus 1 2 theta d theta. Now let us put 2 theta is equal to phi, and this gives 2 d theta is equal to d phi. So therefore d theta is equal to d phi by 2. Now when theta is equal to 0, then we get phi is also equal to 0. When theta is equal to pi by 2, theta is equal to pi by 2, then phi is equal to pi. Therefore beta of m comma m is equal to 1 by 2 to the power twice m minus 1 into integration from 0 to pi sin to the power twice m minus 1 phi d phi. So we get 2 to the power twice m minus 1 beta of m comma m is equal to 2 into integration from 0 to pi by 2 sine to the power twice m minus 1 phi d phi, and this is nothing but beta of m comma half. So therefore beta of m comma half is equal to 2 to the power twice m minus 1 beta of m comma m. Now let us prove the second relationship. So we know that beta of m comma n is equal to gamma m into gamma n divided by gamma of m plus n. Now applying this formula in this relationship, we get gamma m into gamma half divided by gamma of m plus half is equal to 2 into 2 to the power twice m minus 1, and this is equal to gamma m into gamma m divided by gamma of m plus m. So gamma m and gamma m cancels from both sides. Therefore what we are left with is gamma of m, this is gamma of m into gamma of m plus half. It is equal to 2 to the power minus twice m minus 1 gamma of half multiplied by gamma of twice m. But gamma of half is equal to square root of pi. Therefore we have gamma of m into gamma of m plus half is equal to square root of pi divided by 2 to the power twice m minus 1 gamma of twice m. Now corollary. So we know that beta of m comma n is equal to 2 into integral from 0 to pi by 2 sine to the power twice m minus 1 theta cos to the power twice m minus 1 theta d theta. So first we put twice m minus 1 is equal to p, and this gives us m is equal to p plus 1 by 2. And similarly we put twice n minus 1 is equal to q, so therefore this gives n is equal to q plus 1 by 2. So therefore this integral now becomes 2 to the power 0 2 into 0 integral from 0 to pi by 2 cos to the power p theta sine to the power q theta d theta. This is equal to beta of, now m is p plus 1 by 2 and n is equal to q plus 1 by 2. So therefore integral from 0 to pi by 2 cos to the power p theta sine to the power q theta d theta is equal to half of beta of p plus 1 by 2 into comma q plus 1 by 2. So therefore the integration from 0 to pi by 2 cos to the power p theta sine to the power q theta d theta is equal to half of, now this can be expressed in terms of gamma functions as gamma of p plus 1 by 2 into gamma of q plus 1 by 2 divided by gamma of p plus 1 by 2 plus q plus 1 by 2, and this gives gamma of p plus q plus 2 divided by 2. Now corollary means something that results from something else. So we will derive two important integration formula using this definition of beta integral. Now let us see that when we put p is equal to 0 and q is equal to n, so simply we put p is equal to 0 and q is equal to n in this expression, then what we get 0 to pi by 2 sine to the power n theta d theta is equal to half of gamma half into gamma of n plus 1 by 2 divided by gamma of half plus n plus 1 by 2, and therefore this integral goes 0 to pi by 2 sine to the power n theta d theta is equal to square root of pi by 2 in gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2. Similarly when we put p is equal to n and q is equal to 0 in this integral, then we find that the integration from 0 to pi by 2 cos to the power n theta d theta is equal to square root of pi by 2 into gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2. Thank you.